Good day, distinguished colleagues, ladies and gentlemen. My presentation is on machine learning algorithm for intelligent prediction for military logistics and planning. My name is Simeon Ajakwe, and I'm presenting on behalf of my colleagues. Presentation, I'll be looking at the summary and the motivation for the research, then the main objectives of the research, the classical surveys based on Ezan literature review, the research methodology used, the results and findings will be discussed, and then prodigious deductions and recommendations will thereafter. First of all, the indisputable reliance of military facilities, machines, and equipment on the availability of petroleum products as source of energy is critical in military logistics and planning for successful tactical operation. Not only that, the need for intelligent and intuitive real-time dynamic logistic deduction and decision-making is critical for military tactical operations and success. Also, the indispensability of the need to evaluate the efficiency of the surging proliferation of machine learning algorithms for optimized performance in military logistics and planning cannot be overemphasized, and this necessitated this research. In a nutshell, this research compared the accuracy, sensitivity, and specificity of machine learning algorithms, namely artificial neural network, the k-nearest neighbor, the random forest, and Bayes. It compares the accuracy, sensitivity, and specificity for predicting availability and possible reorder of level of ministry logistics. At a glance, the finding shows that the artificial neural network had the highest accuracy. This is closely followed by the k-nearest network. The specific objectives of this research was to review machine learning algorithm used for prediction in military planning and logistics. Not only that, we also used explorative mixed method to collate, classify the prices of petroleum products for military vehicles and operation. Thereafter, we utilize this derived data set to be able to design, train, and simulate machine learning algorithm to make future predictions. Thereafter, we perform systematic and complexity analysis of the existing algorithm and made proposed algorithm to ascertain the difference in key performance indicators. Based on Ezan literature review, we were able to discover that accurate pricing, estimation, and accurate prediction of what is available and what to be put in stock is considered very crucial in efficient military logistics and planning. Also, several algorithms and models are used in military logistics, which include the SVM, the GBM, the GPR, the ANN, and the CNN. Each of these algorithms has its attendant weakness and strength. Furthermore, we're also able to discover that the demand for oil and technological progress in military informatics has increased the supply chain management in military operation. Then we also were able to discover that significant breakthroughs had been recorded in the development and deployment of efficient computational steps in tackling complex data and event-driven problems across all domains with high efficiency and accuracy. Finally, we're also able to see that other areas of military logistics are gaining attention in predictive model for military planning. This is the basis research. The research methodology that was used in this work is the explorative mixed design, which made use of both the secondary data and the primary data, and thereafter this data set were subjected to data analysis using Python programming language. Based on the results collected, the result of these algorithms, they were compared using accuracy, sensitivity and specificity to evaluate and appraise the performance of each of them using the formula on the screen. Like I said earlier, the Python programming platform was the basis for algorithm evaluation and comparison. The objective is that algorithms with high accuracy are considered better than the rest. The results from this from the analysis indicates that the artificial neural network had the highest level of accuracy. Then the random forest had the highest in terms of sensitivity, as seen on the figure on performance evaluation and comparison of algorithm. In a nutshell, we're able to discover that based on evaluation that the artificial neural network had the highest accuracy value of 85.57%. This is closely followed by the k-nearest neighbor, the KNN, with accuracy value of 74.98%. When it comes to sensitivity, it was also discovered based on evaluation that the random forest had the highest sensitivity value of 80.58%. This is closely followed by the Naive with a sensitivity value of 79.49%. In summary, we were able to discover that the artificial neural network had the highest, accuracy figure of 80%, 86%, and based on that, the artificial neural network is chosen as the best machine learning algorithm for intelligent prediction in military planning and logistics. This result is consistent with previous research in this area. Based on the evaluation and results of the results, we're able to conclude and to say that the deployment of artificial neural network in optimizing military planning and logistics is an efficient solution for successful tactical operation and intelligence, and therefore should be used in military logistics and planning. Also, optimization of logistics processes helps in efficient vehicle routing and effective service delivery. Therefore, beyond military logistics, this can also be used in other logistics. Not only that, the benefit of deploying machine learning algorithm in intelligent prediction of military planning and logistics include but not limited to proactive supply chain and value chain derivation, informed and intelligent decision-making process, competitive advantage, and continuous availability of supply of critical resources to the military cannot be overemphasized. Based on this, we hereby recommend that more research and development should be done in this area, and future research should consider doing critical work in testing other machine learning and deep learning algorithms to ascertain its efficiency and optimization for logistics. Thank you for your rapt attention.